Hello, hello. Welcome everyone. Just let another one in. Hope you are all well. We were just having a little conversation about the role of the mainframe around the back in IT suites around the world, and you're going to hear some more about that and in detail on some of the strategies for making the best of your storage. Hope everyone is good. I'm just going to let some more people in here. So I must say this is a nostalgic pleasure for me. At one point, the ZCMPA stream, which you're currently listening to, was called the UKCMG stream. So the UK branch of the CMG, the Computer Measurement Group, kind of all the guys interested in performance and capacity, had this as a stream as part of GSE, and I, for my sins, was chairing the UKCMG at the time. So it's a wonderful, nostalgic feeling for me to be hosting performance and capacity people. So I am going to get out of Paul's way because this is a gentleman who is no stranger to giving a presentation, and we were just talking about his background and experience, and he's been in the field for many years and understands both sides of the fence, both mainframe and open systems. So I will give him over to you. Please, if you've got questions, I will save them all up in the chat, and at the end we will go through them. And please do remember to fill out the feedback for this session. So this is the first time that we've run GSE all online, virtually unstoppable. It was a tagline I came up with because I love a pun, and we'd love to see how this works for you. So please do fill in the feedback forms. Righty ho, me out of Paul's way, and we'll have some questions at the end. Thank you very much. Over to you, Paul.
Well, thank you for that intro. Have we waited long enough for everyone to get in the session, or would you need to get a couple more minutes?
I will keep letting people in. As people turn up, I will keep throwing them in the bear pit.
All right. Well, I will take a minute or so just to do a brief introduction then, and hope that a couple more people can join. That way they won't miss anything. Thank you for your time today. I hope you have some good questions on this. I will go ahead and let you know that this session will be just a little bit shorter than the time allotted because I am hoping for some questions. It's a very interesting topic to me. I was a storage administrator for many years at one of the largest banks in the US. And so I had to deal with this on a daily basis, taking care of HSM processing. And it always was one of our top 6 CPU consumers on our mainframe back when I was doing storage administration. And now when I look at my customers and we run these reports, it is continually in the top 6, 7, 8. I really never see it lower than 7 or 8. And sometimes it's up in number 2 and 3. So, well, we spent a couple of minutes now with an intro, so I'm going to go ahead and share the screen and we can get started on this. Okay, there we go. Please let me know if there are any artifacts on the screen or anything that's in the way of the presentation. If so, I'll try to fix it for you. But my name is Paul Massengill. I'm a systems engineer at Luminex Software. And specifically today, what we're going to talk about is how to put HSM on an MSU diet. As I mentioned, I've done this in the past as a customer for many years, and HSM was continually one of our highest CPU consumers on the mainframe. And at Luminex, what we've always looked for is what is something that almost all of our mainframe customers have a need for that we can help them solve very quickly and simply. And that's why this presentation is actually going to be a little bit short today, because other than showing you some reports from our customers, how we can solve the problem, it's a fairly quick solution. And then I'll show you the reports that show you how much you can save at the end. And by the way, we can actually run those reports with just a little bit of data from anyone. So you could run it yourself, look at the results and see, you know, would this be something that would actually help in the environment that I'm trying to manage? So I am trying to get the slide to go forward. Now, despite what some people think, this is not me at lunch trying to take a customer out. No, instead, this is really just a representation of how much CPU HSM is going to consume on a continual basis if you allow it to. And it's not just an individual business's issue. In fact, there are many, many papers that you can find, and this is just a quick subset, trying to help you improve the performance, because everyone realizes that HSM really does take both CPU and IO resources continually on your mainframe. And we're going to talk to you about a way to help reduce that overall. And the nice thing about it is it doesn't require a lot of changes in your environment like some of these white papers talk about, where you have to actually implement some best practices and you have to continually go back and review those best practices and make sure that they're being effective and make changes. Instead, quite the opposite. And I'll explain that in detail in just a minute. So when we start running reports for our different customers, and for our mainframe, we have a mainframe ourselves where we do our development work. These are the type reports that we see, and you see number 3 here, ARC CTL. That's one of the acronyms that you'll see for HSM workload. Now, as we all know, HSM is going to be consuming CPU when it archives data off primary disk, when it moves data between the ML1, ML2 layers, when it recalls or restores a data set that's being recalled, and also when you're doing recycles. Now, the only thing that you're going to be able to do for the archive and the restore is just buy more primary storage so that you're not having to do that as often. But the thing that we could help you with would be the recycle. And we're going to be talking about that in detail in just a few minutes. So this is actually an example from one of our customers. It turns out they're number 3. And when you look at how much total service you're getting off your CPU versus number 1, okay, it's significantly smaller than number 1, but it's a lot bigger than number 10. So there is a lot of potential savings when you look at this. This is another report from a different customer. And again, you see HSM way up there, number 3 position, particularly when you look at over on the right-hand side, total amount of IO that's being consumed. So a lot of time spent having to handle that IO. And then this is our 3rd customer. Again, turns out HSM was number 3 as far as CPU. A lot of connect time, a lot of EXCPs. It's doing a lot of IO. Now, some of this, it really is a looking at and tuning to make sure you're not archiving things too soon. But then you have to look at, if you're not archiving things too quickly, do you have enough primary storage? That's going to be a separate issue. But once you have it and it's in ML2 and things start getting deleted, like GDGs are rolling off, data sets that have been archived are no longer cataloged, so they've been deleted, you really start creating what I call Swiss cheese on the ML2 layer, because when you're writing this out to ML2, whether it's a physical tape or it's now virtual tape. Almost everyone's moved to virtual tape now. You still have a container file for HSM when everything's being written, and it's usually the size of a full tape. And as things get deleted, those blocks that make up that data set within the HSM container file are not returned back to the pool. So that's why you have to eventually do a recycle. At some point in time, you're going to have enough deleted data sets, or deleted blocks from data sets, I should say, within the HSM container file, that you have a large portion of that container file that doesn't have valid data anymore, but it's still holding the full amount of space. And that's when you have to do a recycle. The challenge with the recycle is it's very CPU intensive. You're going to have to read those full tape data sets back in, throw away the old blocks that aren't used anymore, rewrite the new stuff out to a new scratch tape, and then release the tape data back into scratch status so that that tape can be reused. The challenge is you're reading a lot of data in, you're writing a lot of data out, and you're doing a lot of record keeping. So then you have to balance between the HSM recycle taking a lot of CPU resources, IO resources to save some storage. And so it's really a balancing act for the storage administrator, trying to determine how much is the storage worth versus how much it costs me in CPU and IO to perform this recycle. So we frequently see clients doing this at least once a week, but some, due to how much resources it takes, they're trying to push it back to only once a month. The cost in that, of course, is increased amount of storage needed in ML2 and additional tapes within the tape range, because now you'll have more scratches taken up with your HSM container files. Now, some of the things that you can manage with your recycle is actually looking at the percent valid, which specifies the maximum percentage of that valid data before it's included in the recycle. If you're trying to save your CPU resources, and I don't see anybody really going as low as 5%, but frequently see people in the 25, 30% range before they allow it to be recycled. But if you think about that, that means that in your virtual tape environment, that container file is using, by the time that it's recycled, say at a 30% recycle percentage, you've got 2/3 of that container file that contains nothing but invalid blocks, yet is holding up space on your virtual tape subsystem. So if that's the case, then you may push your percentage a little higher. Maybe you say 50%. So you're going to be recycling tapes much more often, but then your recycle is going to run longer now because you have more tapes to read in, and also you have more data that's valid on those tapes that you read in. So again, you've got this balancing act going on. Where do I set my valid percentage rates when I'm doing these recycles? Again, not to waste any more CPU resources than I have to in IO, but at the same time to quit wasting storage space out in my tape pool. Now again, the challenge with the recycle is that the DFSMS HSM task, especially when you have logging turned on, does consume a fair amount of resources. And that's dependent upon the number of tasks that you have currently running, the fact that it's having to continually update the controlled data sets, the CDSs. And then you also have the IO, which is relatively minimum compared to those other things that I just listed, but you still have the IO with reading in those container files, picking out the good data sets, and rewriting them out to a new valid tape. So that stuff takes a lot of time as far as wall clock, takes a lot of CPU, and takes a lot of IO. It turns out that when you actually do a study of, where the resources are being consumed with this, the majority of the overhead during that recycle is actually in updating the control data sets. You see the CDS is being opened and closed each time a new data set is read back in. So there's a lot of record level CPU consumption that's going on there as you're doing a lot of updates to the CDS. And just a little performance hint, you want to make sure that you do not reorganize these control data sets unless you just absolutely have to, because what our customers frequently see, and we do as well on our system, is that if you do that reorg on the control data set, you actually see a performance degradation, usually for up to 3 weeks following that reorg. Now, if you're trying to measure it, and many of you probably already have some reports in place to do this, but you can look at your function statistics record, the FSRs, and the control block. It contains statistics about different particular functions. So those of you that are performance tuning capacity planners, you're probably already looking at this if HSM has been defined as a problem issue in your shop. But I'm not going to read everything off on this slide. These slides will be available later. So if you want to, look through it again later, you can. But the important thing is it really tells you when everything's starting, stopping, the recycle time, how it's being consumed. So you can actually go and look at this and really break apart your HSM CPU usage and get some good feel for what's happening during these recycle activities. Now, let's say you want to try to just avoid recycle. How are you going to do that? Well, the truth is about the only way to do that is to buy more DASD. So if you have a lot of DASD on the floor, you can not archive nearly as often. You can let data sets live out their life on primary DASD, and then you don't have to worry about this. But who has the budget for that anymore? Our mainframes have been run very efficiently, and so people are used to the fact that they're not buying a lot of storage and adding to that DASD farm, and so it's really hard to get the budget. And a lot of times you just don't want to have all that DASD on the floor. So what's another alternative to this and still saving the CPU? Well, what we've done is we will help you optimize your HSM ML2 tape capacity, but doing it all off host. So you don't have to run through the mainframe to do this anymore. Essentially, you have no FICON IO associated with this off-host HSM recycle. And you can run it reasonably frequently now, since you're not impacting CPU on the mainframe, you're not impacting IO on the mainframe. And so you can keep your expired data set usage very reduced because you're just not impacting your mainframe when you're doing this recycle. The other nice thing about this is the VolSeer and the block IDs all remain the same. So you don't have to update the HSM catalog. The CDS that we talked about, the updating the CDS that creates a lot of the workload. Well, that doesn't come into play for this because we do not change the VolSeer and the block IDs remain the same. Now you say, but well, if the block IDs remain the same, you're not changing the VolSeer, how are you saving any space? Well, we're going to go into that in detail just a minute. But what we're able to do is take all the extra gas out of those expired data sets, leaving the block IDs in place, but returning that free space to the pool. So what happens is your performance continues to improve. The first time you do this, your tapes will physically get smaller. Those container files will actually shrink and not take up as much space. Then that allows for a faster cloning process as we're doing the copy from one tape container file to the new one, because you're not moving as much data each time. And then if you're replicating your HSM off site, those smaller container files don't have as much storage in them. Therefore, they will replicate faster because you're not moving as much data. This actually helps you then reduce your reliance on the mainframe resources. You're not having to do all the CPU consumption as you're updating the CDS. You're not doing the CPU and the IO to copy these files over, because it's all happening off host. So then the result is you can do a more frequent optimization of your ML2 and take up much less total capacity. The hope there is that then you can delay your storage upgrades as far as upgrading storage associated with your tape pool. And you can also hopefully delay storage upgrades on your primary DASD, because you can be able to archive as aggressively or even potentially more aggressively in the future, because you're not consuming as much CPU, IO, and storage resources with your HSM. I'm going to step through the process now in detail, and let me know if the right side of the screen is covered up, because I have the listing of everybody in the meeting there on the right-hand screen. So I'm hoping it's not covered up. If it is, let me know. So we put a program on the mainframe. That mainframe, when you call for an HSM recycle, will go out and read the information out of the CDS for invalid data sets. Now, this can either be each time you run it, you can either look at everything in ML2, you can subset it down with different criteria. That's up to you, and I'll talk about that criteria in a minute. But we read the CDS on the mainframe. We deliver that report out to the appliance, and that report shows us the data set names that have been deleted. They're now invalid, and the block IDs associated with those data sets that are part of the HSM container file on the tape vol.seer. For a brief period of time, we actually lock that one vol.seer associated with the task at that time, so that you can't have any IO. You can't write to it. You can't read to it for just a period of time while we're making a copy of it. While we have it locked, we go through and we read the tape and we write it to a new version of the exact same vol.seer. Now, we're doing this internally on the appliance. You cannot see this happening on the mainframe at all. The mainframe will always think it has the exact same vol.seer with the exact same blocks on it, which is what's pretty cool about it. As we read through and we see a data set that's been deleted out of your catalog on the mainframe, we'll replace those block IDs associated with the data set that's been deleted. So we'll take the 16K block that has invalid data in it now, and we'll replace it with just a 16 byte header block. So the block ID stays the same, but we took all the gas out of it. So we took all that extra free space that was holding invalid data, and we just replace it with a marker. Now, if it's still a valid block because it's still a valid data set is contained within it, then we just copy that over. So it's only the invalid data set blocks that we're shrinking. We keep the same vol.seer, we keep the same block IDs. Because we do that, we do not have to go back and update the HSM CDS. And then the nice thing about it is, if you think about it, each time we're taking the extra space out of this container data set, it's getting smaller and smaller. Therefore, we can read through it faster and faster in future updates. So your performance will continue to improve. All right, so we have read the good data sets and copied good data sets in their blocks over and created a new tape. We took the bad blocks, the ones that were invalid, we left a marker for each block, but then we didn't write out that data payload that was behind it that was invalid. So we have 2 copies of that tape Valseer on our appliance at this time. Then we mark the new one as the valid copy, and we release the lock. So then if anybody needs to restore data set off of it, they can pull the data set off of that new tape. Now we realize that when you put this technology in place the first time, you might question how well it does its work. So we actually have a parameter on there, and you can tell us how many days to keep that copy of the old tape before we actually delete it and free the space up within the tape pool. But that's up to you. You don't have to keep it at all, but you can specify a grace period and say keep it 2 or 3 days just to make sure that the technology is working well for you. So that is a step-by-step process of actually what we're doing. Now we're going to step inside the container file, and we're going to look at how does this really impact what's going on. So let's assume that up here before, on the top half of the page, where you see the Valseer, as an example, ABC123, has 1 million blocks of data. Those blocks are 16 kilobytes each, 16 gig. Before the recycle, you've actually deleted out of your catalog on the mainframe everything that was in DSN1, everything that was in DSN3, but the rest of the files on here are good. Within each one of those files then has a bunch of blocks associated with it. Well, for DSN1, he actually owns 50,000 blocks, each at 16 kilobytes each, 800 megabytes of space that's invalid, but you're still storing it because it's within that container file. The same thing with DSN3, 100,000 blocks, 16 kilobytes each for each block. So you've got 1.6 gigabytes of storage that you're taking up within that container file, but you're not really using because the data set's been deleted. Maybe it was a GDG and the GDG rolled off and it's not valid anymore. It's been cataloged on the mainframe, but you're still holding that space in your tape storage. Well, we would go through the process I just described, where we read out of the CDS which of these data sets are invalid, which block is associated with the data set that's now invalid. And we go through and we replace all of those blocks with just a block header instead of the whole thing. And so what that does for us is it takes the 16K blocks, 50,000 of them in the case of the first data set, down to only 16 bytes each. Now, because we are preserving the block IDs with that 16 byte block header, we don't have to change the HSM CDS at all. So now instead of taking 800 megabytes, you're only taking 0.8 megabytes. And for DSN3, where before you were 1.6 gigabytes of storage, now you're down to 1.6 megabytes of storage. And again, we're doing that to preserve the records within the HSM CDS because that update is most of the CPU consumption when you're doing a recycle. And so then you see that that changes your container file from the 16 gig down to 13.6. Now, again, this is just an example. Usually when you're doing a recycle, you're going to have half of the data sets, therefore, half or more of the blocks on the container file that are invalid. So there's a much bigger savings to be realized, but we're doing this just as an example so that it's easy to follow. Now, there are different control parameters that you can set when you're running this off-host HSM recycle. As an example, you can say delete equals yes. Delete equals yes means that when you go through this process, you're actually going to delete those invalid blocks and replace them with the 16 byte block instead of the full size block. You can select a portion of the vol sears that are part of your HSM pool. As an example, the first select statement here selects everything in level 2, and anything that has a percentage of invalid data more than, equal to, or more than 30%, it's going to be part of the recycle. So if only 10% of that vol sear is invalid, it won't be part of the recycle. But if more than 30, or well, more than 30% or more is invalid, it will be included. The next select shows an example where you only want vol sears with the first letter of D in the vol sear to be included in this process. And then only if the amount of storage that is invalid on that vol sear is greater than 5 gig. So you can go after your heavy hitters like that. You can say, hey, if I'm going to return at least 15, 20 gig each time I run this, those are the ones that I want to hit first. Or you can just say, I only want to do this for one volume, and that volume is, and you can specify it. Now, the reason we do this is this allows you to run some reports, see what's going to happen in your environment. It allows you to actually run the process on a very limited scope, so you can run it against some of your test vol sears that are part of HSM before you actually go live with it. So it gives you a lot of control of the environment and a lot of control of the reports that we generate. And I'm going to have some reports I'm going to start showing you. We don't just tell you to run this and hope everything goes well and hope you get a good return. We can actually show you what you're going to get from your return with these select statements and with a delete of no. So you're not actually deleting anything. You're actually going to delete equals sim. So you're just going to simulate it occurring, and then we can get some reports out of it. And here's an example of that. So you could run it, and your selection says delete equals sim, simulated only, do not actually do anything with the HSM off-host recycle. Just select this and give me the report. Let me know what would happen. So again, the same select statements can be used. You could select just an individual volume, but only if the percentage of deleted blocks on there is greater than 20% of the volume. Or you could use a wildcard, so you get ABC 1, and then anything after that, as long as it's in the HSM pool, and the percentage is greater, is 20% or greater in deleted block IDs. You can also say, I would like to do the delete, but I only want to do it on the alternate copy. So when you've written your data sets out in archive to HSM, a lot of customers will create 2 copies, not one. So they'll create 2 tape copies to make sure they have a backup. So only do this against the alternate volumes. Don't do it against the primary volumes. So that's another parameter that you have capability of controlling this. Now, the result of that sim, or the result of doing it live, you get the report either way, is a report that shows you, as an example, if this were sim, this would show you what would have happened had I let it really happen. And it lets you kind of look and have an idea of, how much can this help me? So let's step through the report and see the different fields here. Well, first off, we're looking at the level 2. So migration level 2. Over on the left-hand side, you see we have valid blocks and the invalid blocks. Then we come across and it tells you how much in just raw gigabytes are you looking at for the valid blocks versus the invalid blocks. And you see this about 12% on this report, only about 12% of the blocks would have been invalid. Now, of those 12% of the blocks, let's look at it in a little more detail. How many of those deletes are still pending, i.e. you haven't run the HSM off-host recycle against them so that that can still be restored back to the pool. So you see that this has not been run yet. So the entire amount of invalid blocks on the container data set are available to be reclaimed and added back into the pool. Then let's look down for the next part. We're also looking at the backup. So for the backups, we have a different sizing, and we see that you got the 4,801,522 for your raw gigabytes. That's how many blocks. Then you have your raw gigabytes, only 73 that are valid, 8 or a total of 10% are invalid. And again, those deletes are pending. They have not actually taken place yet. If this had already been done, you would see that the invalid block percentage would stay the same, but down here, you would see this 8 move from pending to actually deleted if you had actually run through the process. So what you're going to look at when you run this report the first time in a sim mode, you're going to go and most likely you'll want to do your entire level 2 tape storage, but maybe you want to do a subset. Maybe you're looking at only your test data sets within your level 2 or something like that. You would see the total amount of gigabytes that are held by valid, the total amount by invalid. Then you would see that your delete pending would be all of the deleted because you had not run this off-host recycle process before. But then you would know that that's how much that you could save in your tape pool and on those container data sets by running this process off-host. So then you can go down with both your level 2, your backups, and you can say, well, if I were to do this in its entirety, this is how big my storage pool is currently. This is how much I could return, and decide, is this a process that you want to take, have run in your environment without using mainframe CPU, without using mainframe IO, just running on the appliance itself. So this is kind of the summary slide. And as I mentioned, we'd be a little bit shorter than the 45 minutes, but with the HSM off-host capabilities, you don't use the MSUs for that recycle. Everything is being burnt on the CPU on the appliance. So you're not impacting the mainframe. You're not having to read the data sets back in off your HSM tapes and recycle it back out to a new tape. So you're saving all that IO on the mainframe. You're also saving storage in your HSM pool because now, since you're not using the MSUs on the mainframe and you're not using the mainframe IO, you can recycle much more often if it's of value to you. You can check it with the sim in place and see, are you going to get anything back? And if so, you can go ahead and run that recycle because you're not impacting the mainframe when you do it. And then by only recycling HSM on the mainframe, you're only going to have to do that fairly infrequently, and that's going to depend on how many vol sears are you taking up in the TMC for HSM. So that's when you're going to actually want to run that recycle on the mainframe, incurring the mainframe MSU and IO cost, but you're doing it because over time, maybe you run it once a month, once a year, you would have to decide on how many tape ball sears you're taking up within your tape catalog to hold these much, much smaller recycled HSM tapes now. So that's kind of the balance. You would take more total vol sears, but again, they're vol sear in your tape catalog on a virtual tape. So it's really a virtual tape. You're not having to buy more tapes just to be able to do it. So but that is your trade-off. So that is the majority of the presentation, other than to just let you know that we Luminex are actually opening a build and ship center in Manchester. And so you're going to have local time zone sales and support. And there's the contact information. I'm going to open it up for questions right now. Do I stop sharing at this point or just leave this up on the screen? I'm not sure of the process. And I'm also trying to find.
Hello, Paul.
Yes.
Yeah, you can leave that up, or you can put that down so it goes to your face so everyone can see you.
Okay.
Oh,
well,
yeah.
I did want to throw this up before I go to scaring everyone with my face being across the screen. So that please remember about the GSE UK Conference 2020 charity, and this is how you can donate. Okay, so I've stopped sharing, but I'm ready to answer questions now. Okay, I see some stuff in chat. How long is a tape lock for during the recycle? Is a copy the alternate tape also recycled along with the original? And they say they suspect not. Well, you're correct. We do lock the primary tape if you have specified in the parameters that you're going against the primary tape, or we would lock the alternate tape if you have, you saw that command that I had, which specified alt. So we're not going to lock them both. So you can get back to your data set just off the alternate copy. And the correct answer, since I am a capacity planner performance tuner to anything, is it depends. And what it depends on is the size of the tape and the size of the container file. So if you're doing an extremely large tape, then we have to read through the whole tape, copy it over. If you're only doing a 3490 equivalent, so it's a really small tape, well, then we're going to do it much faster. But we're only talking a couple, 3 minutes. I mean, it doesn't take long to even do a large tape because we're staying within the appliance itself. So we're actually doing an internal disk-to-disk copy and preserving only the data that is still valid, switching out the invalid data for just a 16 byte marker. So it actually goes pretty fast. Any additional questions? I don't see any other questions in chat. If you want to type it into chat, I'm happy to answer it. This presentation will be available too, and it has my contact information. So if you come up with a question later, feel free to send me an email or contact me, and I will be happy to get the answer back to you.
Paul, I have a kind of a general one. Clearly, you're somebody who sees a lot of different sites. I wondered if you could say anything about the trends that you're seeing at the moment, or the kind of the new challenges that people seem to be addressing in this area. Has everyone moving online, and kind of the sudden increase in online payments and hence kind of storage of records and stuff, has that had an impact? Can you say something about what you're seeing, the world as you see it at the moment?
Yeah, as you and I were having a discussion before this, and I was talking about the fact that for the last 25 years, people have been saying the mainframe's dying and everybody's trying to get off the mainframe. I do see very small shops that are successfully getting off the mainframe and moving their applications to open systems, but only the very small shops. For the larger shops, not only are they maintaining the size of their mainframe, but they're mostly growing it because of all the things that you mentioned. One of the biggest challenges that I'm seeing with the mainframe environment now is with the proliferation of distributed systems in the environment, a lot of the core information owned by a business is still residing on the mainframe. So they're getting a larger and larger amount of calls for information to be shared within their internal enterprise. So I'm seeing a lot of customers now that are starting to have problems with their TCP/IP stack just being overwhelmed with all of the requests that they have for data going to their internal shared enterprise servers, and they're starting to have problems keeping up in some cases. That is creating more storage needs on the mainframe because they're keeping more records or more copies of databases so that the data can be shared at the same time to many different locations. So I'm not seeing the mainframe shrink in the larger shops at all. In fact, just the opposite, it's growing widely. In the very small shops, we have seen several of our previous customers that have finally managed, after years and years of trying, to get rid of their mainframes. But for the most part, the mainframe is very vibrant and growing. Did that answer your question?
Yeah, no, did. Thank you very much. One more thing that you might have a view on. Expanding the capacity of the system, often that takes some advocacy skills on the part of the manager or the operator. I wonder if you've observed any particularly good strategies or any particularly good examples of people making a good case for how they can get access to the type of services that you were talking about.
Yeah, the good thing and also the challenge of the mainframe is with the SMF records, which really aren't available on distributed systems, capacity planners, performance tuners have usually very detailed understanding of their growth rates and their needs on the mainframe. Where many times, if you're looking at distributed systems, it's a little bit more art associated with capacity planning and those environments, where you can have a little bit more science, if you will, associated with capacity planning on the mainframe. That's good and bad. The enterprise is used to the mainframe being very resource efficient, not needing a lot of growth, and therefore they're used to not putting a lot for them in the budget. And that becomes very hard then to change that as the demands on the mainframe for information to be shared within the enterprise becomes larger and larger. But the good news is that we've got the data available. We just have to put the requests in front of the right managers at the right level sooner. As you start seeing new applications start coming online, you have to start projecting that impact as soon as possible and start pushing for the added resources as soon as possible and start changing the way they view us. Now, another thing associated with the mainframe is that data is usually considered very secure, and it's usually very important to the entire enterprise, kind of like the system of record for general ledger usually tends to be on a mainframe device. So when you're putting forth those requests, you have to be able to also subtly, but in business terms, talk about the impact to the enterprise and why it's important to get those resources. Because again, you're talking to managers that frequently are removed from just simple IT, and you need to put it into business terms and business impact for them so they understand why am I going to be willing to make this investment? So hopefully that answers your question.
Fantastic. Yes, it does indeed. I bet you're all glad you stayed for that. So, thank you very much. I think we can show our appreciation to Paul by maybe giving him a quick wave.
Well, I do want to thank everyone for your time today. I hope you did get something out of the presentation. The presentation will be available if you need to contact me later. And I hope you have a good rest of the conference and get lots of good information. Have a great day.
Thank you very much indeed. Cheers.
Cheers.